Okay, it looks like we are live. So welcome back. I'm going to be continuing to work on the compiler. I will put the code in the chat. Alright. So I've been working on it off stream a little. Not very much, honestly. Just to fix the problems from before. So before, we had it almost completely working. The problem was that it was printing out the numbers. And then it stopped printing everything else out. So the way I fix that, if we go into, let's see, that's not show it. If we go into the code generator, and let's see, it was all the way down. Basically, what we were doing was in the right, right in here. So what would happen, we were moving RDI to this. Hi there, how are you doing? We're moving RDI to this, and then we were not sending it back to 1, which is standard out. So that was causing the problem, making it not work. But that is fixed now, so we can technically have FizzBuzz now. So by going to test.on, this all works. Run this. Alright, that works. But FizzBuzz, so to do that, we need something like that. We have to do it a little weird because of the restrictions of the language, but it works. So while there we go. Then what we can do is remainder 3 equals that. Remainder 5 equals this. And then remainder 15 equals this one. So then what we have to do is check remainder 3 equals 0, and remainder 15 does not equal 0. And then we just write fizz with the 5, so now we'll give it a new line. And then we check remainder 5 equals 0, and remainder 15 not equal 0. And actually, I'm thinking there's a better way to write this, but I'll rewrite it after. Buzz 5, and then now we have to check if remainder 15 equals 0, then so EQ basically is just my way of doing equals equals, and then NEQ is not equal, basically. That's all it means. That way it's somewhat different from, and it's not basically just C syntax, just to give it something unique, you know? So that's what it is. It's just a keyword, basically. Then we want to write FizzBuzz, and that is 9. And then we need to check if remainder 3 not equal to 0, and remainder 5 does not equal 0. Then we write I and 2. Alright, and then we have to also I equals I plus 1. And we don't have I plus plus or anything like that in the language, so we have to do it this way. Whoops. Alright, now if we build this, if I did everything correctly, alright, there we go. FizzBuzz. So all the way up to 100. Wait, shoot. Actually, here, we want to start I at 1. So I did mess that up, actually. There we go. Okay. So the first one, 1, prints that out. 2, we get to 3, so we print fizz. If you aren't familiar with FizzBuzz, basically what it's doing is, it's a multiple of 3, then we print fizz. If it's a multiple of 5, then we print buzz. And if it's a multiple of 3 and 5, then we print FizzBuzz on the same line. How did you implement right? I will show that. But yeah, you can see that this works, and we get to 15 FizzBuzz. So it is working. There's a couple things I'll go over, but first I'll show how write works. So basically, I'll show how we do it in the program, and then what it looks like in the generated assembly. So in the Lexer, that's where we go through all the symbols and we convert it to tokens. Basically, we just check if we have write, and then we set the keyword. And then the parser, which is where we check the syntax of the code to make sure it's all right, and then also convert it to an abstract syntax tree. Let's see, if we go to write, let's see, hang on, handle write node. Alright, so we start with write node, we initialize it, and we basically generate the node. So then it generates, I can show what the tree looks like. I have a lot of debug stuff in here, but let's see. all the way up here, yeah, we have the nodes here, which this is basically just a tree. So I can actually kind of draw what it looks like so you can get an idea. Basically, you have the main node, which is just a program node. It doesn't get converted to code at all. It is just the main node. And then to the left of that, you have something like where you declare a variable, so then int, and then to the left of that you have x, and then to the left of that you have equals, and then to the left of that you have 5, something like that, right? So then that's how that would look. And then to the right, you would have the next token, right? So like right, something like that. I can't spell it all because I just have a mouse, but that's basically the tree that it generates. And then the last step is the code generator. This is where we traverse the tree and we convert each of the nodes to the corresponding assembly code. So here's the right. So basically, let's see. I have to remember how I do this exactly. Alright, yeah, so we check to see if there's a variable, which we only have integers in this language. So every variable is an integer. And then we get it, and if the value is not defined, then we print that. That's just error. So if it's a variable, then we handle it like this, which basically just uses printf, which is just like a libc thing. But then regular printf, which is like this, right, with a string, basically we make the node. This is the value of the text that we have, and then we do this. And if I open up the generated assembly, in here, let's see, if we go to right, this is basically how it works in assembly. So you make a section.data, that's where you store the data, and then this basically is saying fizz with a new line at the end. That's what the 10 means, and this is just the identifier for it. And then we go back to section.text, and that's where you write the actual assembly code. And then we move, I can actually open Chromium. This is like the syscalls. Basically, you do it with a syscall. So you move RAX1, that means right. So this, whatever you put in RAX corresponds with whatever this is. So if you were reading, you would do 0, stuff like that. So 1 is right. And then here, this is where you put what it is writing to. So 0 is standard input, std in, I guess. And then 1 is standard output, and 3 is standard error. So that's basically the corresponding. We just do 1 because we're just assuming standard output. And then RSI, that's where you put the actual string. So in this case, we put text 0 into RSI. And then this is basically the length of the string. So RDX is 5, because that's the length with the new line, because the new line counts. That's basically how we generate it. So I could actually make, if I just kind of clear all this, it's a lot of assembly. I can sort of show, basically, we'll actually want a section.data, and then we want to make just a text. It can be called whatever you want. Text db hello world, for example, and then you put 10. And then yeah, you move RAX1 and you move RSI text, and then you move I think it's RDI, right? It's RDX. Okay, RDX. You move yeah, I use syscall. Yes, indeed. Yeah, so 14, and then you also have to move RDI 1. And then yeah, if I just build the assembly here, whoops. Yeah, then I messed it up. Shoot. Let me see, RDX, RDI. Oh yes, I know what I did wrong. I need to change back to section.text. Alright, now it should work. Alright, yeah, hello world. So that's basically how it works. It's, yeah. Alright, yeah, so that is what it generates. This is the generated assembly code. It is not optimized at all, not in the slightest bit. But yeah, you can sort of see how it takes shape. Like, these are the labels for jumping in the if statements. This is the text, obviously. This is when we are working with variables. This is like comparisons and stuff. Does your write accept formatted strings? No, it's not. So it just, basically all you can put is just a string. Like, that's it. That's all you can put right now. Or you could do write and then a variable name. not just an integer, but it has to be a variable name, and then yeah, whatever length. That's all it accepts right now. Yeah, so just a string or an identifier. Yeah, so you can sort of see how this takes shape. This is like the loop, the main loop that we have, and then at the end we have just exit with 0. So yeah, FizzBuzz, and that was the goal of this language, was to be able to write FizzBuzz, and it works. So I am quite happy with that. So yeah, so today I am going to just kind of clean up the code a little bit, and then add some better error handling, because right now there's a lot of problems with it. So just trying to make it a little better. And then I'm going to be done with this specific project for now. Great. Thank you very much. Yeah, so today is probably going to be the last stream where I'm building this project. So I'll talk more about that at the end. Yeah, so basically what I want to do is, the main thing is to add line numbers. So I think I can do something like size t, line number, right? And then what we can do is, as we iterate through, let's see, just right at the end, else if current index equals new line, then we can just do let's see, yeah, line number plus plus, and what we'll do is we'll make a not a global, but just in here we'll do line number started at 0, and so we iterate plus plus, and then what we can do in the generate token, let's see, we can just set actually I think I'll just make it a global variable, so that way I don't have to pass it to every function. That might, yeah, so I'll just make size t line number, and then start it at 0, and if I go down here I can get rid of that, and then in each function I will just set, you know what, I can actually do it just at the end of the loop here, not at the end of the loop, but at the end of each iteration. I can do token line num equals line number, and that should work. There's a lot of warnings in here. I should probably fix some of those also. Alright, and that actually breaks down. Let's see. Not sure why it breaks it actually. Yeah, line number to show better errors, because basically what I want is like error expected semicolon on line number, basically, just to make it a bit easier to debug and stuff when you're working with. Yeah, so I did mess something up here. Let's see, if I get rid of this, I'm pretty sure that's what caused me a problem. No, wait, it's not. Okay. So it must be when I am changing. Oh, you know what? Might be in lecture_f.h. This needs size t line number as well. Then let's see, does it work now? Yes. All right. So that was the problem. So now there should be a line number in each one, so we can print that actually. If I open main.c, and let me just comment everything out here. Yes, and then in here, let's see, actually that is in here. Token. Whoops, that's the wrong file. Print token, yes, and then we just want to print token value, and then we'll just print the line number. Token.line number, and that should print it out, hopefully. Let's see. Let me see. Let me format this a little better. I'll make it a separate print statement. Print F. Then I'll be able to see it better. Token dot line. So it looks like they're all 0. Yeah, 0 or ooh, okay, because that's printing each character. So actually, I want to do that. Yeah. Let me line number. Okay. Yeah. Alright, there we go. Now we can see it a little bit. So line number is 0. So that is not quite right. I'll put this after here. So that's not good. Let's see. Line number plus plus. Alright, let's see. Did you forget to... No, because maybe I need to check the current index better. Alright, let me see. So I'm assuming that this is just never running. Let's see, it'd be up at the top. I think there's a lot of tokens in here. Alright, so that is running. Let's see. Let me actually printf line number, then line number. Let me actually go into here and just disable that, because then we're not going to print the tokens. Okay. Yeah, so the line number is iterating properly, so it is just something with being stored in the token. I think actually I need to do this in each one of the. Well, actually I can just do this at the top, right there. So let's try that. That might work. Actually, I can't check now because I turned this off. Okay, and now we are parsing it as well. I don't want to do that. Alright. Yeah, it still doesn't work. Okay. So perhaps I need to do something different. Let me try with in the generate separator. Alright, yeah, so that is just the problem. It's just memory allocation thing. So I'll just, let's see, I can do that. Yeah, well, weird. That's just kind of how C is. But yeah, that it makes sense on like a lower level kind of thing. Alright, let's just do token line num equals malloc size t, and then token line num equals line number. Alright, then that should work. Nope. Okay, I still did something wrong. That works in here. Yeah, okay, so I'll just have to put it in each one of these functions here. Alright, and that should be good. So now, alright, yeah, and these are all, alright, well I can check. So 5. So that is on the fizz. Fizz is number 7. Is that correct? Almost correct. So the problem is we're starting at 0, and that's not done with Blender. So I can fix that pretty easily. Just make this start at 1. And then it will be correct. So the exit is on line 28. 28. Alright, yeah, so that looks like it's good to me. So now in the parser, basically whenever we print an error, which for the most part can be here, on line number that, and then we can just do, actually, not passing the token here. So let me see. Print token errors, handle token. Okay, and this passes the current token. So current text, and then we can also just pass current token line number. Yeah, and then that should work. So now if we go up to the print error, first one, print error, no, right here. Alright, now it should work. On line number that, and line number, and then we'll take size P, line number, and it should work. Oh, I have some problems. Oh yeah, now I need to change it every instance of print error. What's error type? I will show that. Let me just do this, and then I can show you. It's just line up. Print token line up. Yeah, it's a string. Alright, let's see. Did that fix it? No. Alright, so I have more print error that are incorrect. Yeah. Let's see, do any more have this? Right here. Alright, it looks like there's just one more. Okay. So that's something else I need to clean up, but alright, oh shoot. Dang, I messed them all up now. I forgot to do current token. No multi. I'm not very good at using NeoVim at the moment. I'm working on it. So there is, I'm quite sure, a way to do that. I'm just not doing it right. Alright, let's see. Fine, no. I can query replace this. Looks like there's no instances. That didn't work. $230. Okay, hopefully that is all good now. It is not. 239. Alright. Now, what else do we have? A lot of error, or a lot of stuff. And I guess there's no, that is the past. Let me clear. Okay. So we have a lot of warnings now. Current node is unused. Alright, well, let me see what happens when I do this. So if I go in here, we can uncomment this. I use lunar vim time to time. Alright, what is lunar vim? I mean, I've heard of it, but I'm not sure exactly what it is. Okay. Alright, yeah, so it's just an IDE layer for NeoVim. I've not used that one. Alright, let's see. Okay, and do we have... Let's test the line number. So if we go in here and forget a semicolon, whoops, and it's messed stuff up. Alright, I need to... Alright, there we go. Alright, now if we build it, we don't get an error. That's not very good. Oh shoot. I think I know why that is actually. But we should get an error if I do this. Yes, on line number 4. And that is... Dang, I turned off line number. I forget what the command is. Alright, well it is line number 3 actually, so that's not very good. Line number 5. Now we just don't get... Oh. Okay, line number 4. So, that is interesting. Does this say on line number 1? I do that. Yeah. Okay, so I guess we do have to start at 0 because of reasons. But that works. So, now we get slightly better errors. That's really all I wanted was a line number because it makes it a lot easier. But there is a problem with write where it doesn't give us an error. So let me look in the parser. We can see, wait, does this work? I guess we don't generate it, so I'm not gonna. Alright, let's see. Right, yeah, handle right node. Could be helpful to chow line number and also character number. What is chow line number? What do you mean by that exactly? Or do you mean char? Like character? Yeah, I'm not gonna worry too much. Like the line number is good enough right now because I'm not gonna be continuously developing this language. So I don't care. A line number is kind of like the bare minimum kind of thing, you know. The character number, I'm not gonna worry about that. All right, yeah. So I was in here. So I guess we're not checking. Ooh, okay. So actually, it's just a problem with my handle it token errors function. Semicolon. Still doesn't work. Okay. Oh, because I didn't remove it. Now it should work. No, it does not. Let me look at what it generates actually when we do that. Alright, yeah, and it breaks. That's what I expected. So I'm not sure why. I'm not sure why it is doing that. What confuses me is how are you generating assembly code? Alright, I will show that. Let me just... I'll explain how it all works. Why does that not work? Yeah, so it... Oh, well, I have it doing this now. So let's do it, whoops. Let's do it on the last one, actually, because that's going to be easy. Yeah, I'm not sure. I don't know. Well, here, I can look at the generating assembly code. That's in the code generator. What we do is we check whatever the node is, right? Because we're traversing through the tree. And then based on what it is, we do certain things. So like the operator code, for example. Let me go here. Basically, this is an external function which basically just checks this is a variable and then moves it the register value. And then this pushes obviously RAX. And then we're basically checking while it's an operator, because the way we structure the tree, I can show you actually. Basically, the way we structure the tree is we have whenever we encounter an operator, we start with the plus, and then to the left is whatever value is to the left of it, and then to the right is the next value. So if it's another plus though, then we have, or any other operator, it can be, you can replace this with whatever. And then yeah, basically the tree just goes like this until we reach the last number. So like this. Basically that's how it works. So while the current node is equal to an operator, what we do is we perform the certain operations, like we pop RAX, and then you check what the operator type is, and then you do add, sub, divide, multiply, or mod. Yeah, and then if it's not an operator, invalid syntax. Yes. And then if it's mod, then we have to push RDX, because that's where the remainder is stored when you do a div. And then it's RDX otherwise, because that's what we're storing it in. Basically, that's just how it works for all of them. A lot of it is very messy though, and kind of inefficient. But yes, that's basically how it all works. And then at the end, we have to do it again for the one last, for the last value, you know, at the end of the tree that is not equal to an operator. So that's basically how the whole thing works. Just based on whatever the current node is, we generate the, and the nodes around it, we generate the corresponding code. If that makes any sense. How are you storing that not enough registers? So we're pushing it to the stack, and basically, if I go over here, it's in here, right? Pushing it to the stack, and then we keep track of the variable's location using like a stack pointer, basically. So I just have a number, and every time we push or pop, we either add or subtract from the stack pointer, and then we can do generated we can do stuff like this, right? So this basically, this is based on where the variable's at. So this is in I, basically, in the test file. We have in I at the top equals 1. So we push that, and then we want to request the value because we're checking it. So we push it to the top, and then we pop it off the top of the stack, and that's how we get the value of it. And then to change it, right, so this could be stacked up, but then to change it, we do, that's going to be all the way at the bottom, actually. It's here. We basically, instead of push, we move, and then we move whatever value we want in there. So it's basically utilizing the stack to store basically as many variables as we want. That's the problem, actually. Yes. So that is what we need to fix. Got it. All right, good. Good. Expected that. Okay, now it should work. Expected that on line number 21. And let me start this. There we go. And then the line numbers are back because I forgot the binding for it. Okay, so if we run that again, line number 21. So that is the correct line. So there we go. Now we have slightly more useful errors. They're still not error checking for everything. Is it trivial to store in the heap with assembly? I actually didn't get into that at all. I've only utilized the stack, so I have no idea how that works, honestly. All the assembly I know basically is stuff that I've learned from this. So, yeah, I have no idea how the heap works with assembly. Yeah, I would like to get there at some point, but I'm not there yet. Yes. All right. So let's see. If we do something like this, we should get an error as well. We don't get an error, okay. That is, well, we might actually, I think we get the error when I open main. If I uncomment this, then I think we'll get an error. It just won't have the line number. I gotta remove it again, actually. Now I have to build it again. And we get no error. Alright, that is very good. Alright, very wonderful. Just amazing. Yeah, I'm not gonna worry about that too much. Because I'm basically done with this language now. So I just kinda wanna clean stuff up and make it a little more clean. Yeah. So something I can clean up is I have a lot of comments in here. That from just stuff that I was doing, it didn't work out, but I didn't want to remove it entirely. Actually, so I'm just going to go through and remove those. It's mostly in the code generator file. Like that. Good night, bro. Hope you stream daily. I won't be able to daily, but I've been mostly every day. Yes. Have a good night yourself. Uh-oh. Something is... Alright, there we go. So this, need to... Okay, let's see. Alright, that seems to be most of it. So let's make sure I didn't accidentally remove any code that is very important. Shoot. No, I need to... Alright, let's make sure I don't need to do that. Yeah, okay, still working, so that is good. Yeah, there's some other cleanup that could be done. namely removing all the print statements that were for debugging purposes. So I will do that right now. That. Not sure why it's freezing right now. There we go. This is no good. What is happening? No, I still want that one. Pooping. It said popping. Okay. Right. There is quite a few of these in here. Dang, I might have to restart my terminal because it is not going well. Let me restart it really quick. Yeah, just kind of do that. Alright, let me zoom in a little bit. And actually, let me make sure it all still works after changing those, because you never know. Could accidentally remove something. Alright, yeah, so that's looking good. Yes, so I will continue to remove unwanted print statements. That could be helpful. Don't need that, don't need that. Alright, I think that is most of them. Perhaps not. Oh, I didn't rebuild it. It is still not all of them. So, I think that is actually we are printing every character. Let's just search every instance of printf, and then we'll go through the one. Oh shoot, there's a lot of them. Not as printf though. This is one we can get rid of. I'll just kind of scroll through like this. Yeah, I want to keep that one. Error. An operator. I think it's not defined. That's all good. This is, yeah, we don't need these. And I think that's what all that was. So, yes, there we go. So that's all the, well, at least most of them. So, whoops. Alright, there we go. So now in the parser, basically all I have is where I'm printing the tree. So I need to get rid of that. Shoot, let me. Alright. Alright, get rid of that. There's not as much in here as the other one. That should be most of it. Okay. Almost. Let me look at all the printf. Okay, that is good in the print tree. We want that. We want print error. Don't need this. Whoops, I got rid of it. This is very exciting stuff. We are nearing the end. Okay, that looks like it should be all of it. Okay, let's make sure it still works. Yes, alright. Okay, there's a few more. Or one more. Yeah, right here. I missed this one. So that should be the last one. I have to build it again, though. Alright, now we just have the Lexer, which is the shortest one. So that should not be too bad. So let's open Lexer. This one. Yes. So these are all fine. Well, yeah, because I just need to not print the token. Let's see. Alright, anywhere, printf. That might have been those were the only occurrences. In here, then we have main.c, we had to just get rid of this where we're printing every token. There we go. Okay, and now it generates without a bunch of output. So now, what I want to do is make it a bit more right? So now we can just put an input file. I want to be able to do the name of the output file as well. So we need to do arg stuff. So let's see. It should be 4. Let's see. Correct syntax. Output file. Actually, I don't need the slash up. I'll just do it like this. Let's see. Let's do not equals. Okay, and then so let me open this one. And I just want to run these directly from in here. So let's do that, and then, whoops. Okay, and then not run this. I'm coming out to make sure it all works. Alright, alright, yeah, and then output file name, so we don't handle that yet, but okay. Yeah, this is something different. There we go. Alright, so it all works. Compiles properly. So now we just need to basically change this to be, let's see. We need to change this to output file. So we need to actually set char output file name equals argv2 Alright, let's see if that works. And we'll just do that. LSD, there we go. It did not work. Let's see why. Perhaps. Okay, let me see, does this Alright, so it is still doing that. Sure, there is something very important that I am missing. Let's see. Let me see. So that is still not working. Not sure what I'm doing wrong exactly. So that's the right number. This needs to be that. Oh, there's an error. That's what the problem is. Oh, okay. Man, I am stupid. I didn't even... Okay, yeah, so we need to do sprintf. Let's do nasm. I don't know. Then carry gcc. And we'll do nasm L4 s.o rv2 rv2 and then in here we can just pass that, and we actually have to specify that here. O-O 2 Okay, and this actually should be UCC. Right, let's see now. Okay, yeah, same thing with F open. Let's see. Output file name. No. Yeah. And then we want nas.asm. That's actually. I'm gonna change that. So let's see. Now there's another error. Oh yeah, I didn't actually put it here. Okay, now for real. Yeah. Oh, let's do this. Yeah, sure. Okay, let's see. Now it. Let me clear. Okay. Error. Alright, yeah, so there is an issue with this. Okay, that. Alright, that is fine. Let's see. Yeah, we need to, yeah, that's what the problem is. That is the problem. No, that's not the problem. Okay. I just want to write X because okay. Alright, there is probably a problem. File name. I can type. Then we can just open file name. Oh, okay. So we are not. Oh, okay. And we'll just pass the output file. Alright, that's what the problem was. So, alright. Let's see. Do we? No. Oh, okay. No. This one. Yes. Is that correct? Alright, and now that is not good. Okay, and there we go. Now we can change the file name, kind of. Yeah, that's good enough. Good enough for me. Yes. So let's see. LSD. So yeah, we can call this FizzBuzz. And let's see. So now we can FizzBuzz.un, and we can just sort of write it again. Let's see. Then 3 equals 0. We can -5 equals 0. Then we will write FizzBuzz. Otherwise, if 0, remainder 3 not equal 0, then we will write I, and we have to increment it, and let's include an exit. Okay, and now we can close out of this. Alright, and it looks like it worked. Let me remove FizzBuzz just to make sure it does work, because I had that before. Okay, looks good to me. So what do we have to do now? Now we can actually modify the build.sh. We will call it un. Okay. Now if we build.sh, build there, so /build/un, FizzBuzz.un, FizzBuzz. There we go. Okay, now I think we can actually make sure that yeah. Okay, now there we go. Now I have it is and it's on my system, so I can use it anywhere. So actually, let me make their examples, and we'll CD in there, and we'll make a little example wall.un. Yeah, and we can just do in I equals 0, while I not equal 101. We can write I plus 1, and we can exit with 0. Now if we do un, and there we go, it prints 1 to 100, well 0 to 100 actually. Yes, very cool, very cool. And I will move FizzBuzz.un into examples. Okay, yeah, so it generates all these files. I'm not gonna worry about that. And wall. Alright, there we go. So we can compile those, and they all work great. So there are problems with it. So for example, in the test file, we could make Fibonacci, right? However, it doesn't work. So I can sort of show that. Let me do iterative Fibonacci, because I forget how that goes. Yeah. So yeah, we can do something like this. So not recursive because we don't have functions, so we can't do it recursively. Let's see. So we can do int x equals 0, int prim, let's do y equals 0, int z equals 0. Got a semicolon. And then int I equals 1, while I not equal just arbitrary number. Then we can do preview, that is x equals y, and we can do y equals z, and then z equals y plus x, right? So let's see. I don't think this will work. No. Yeah. Build slash un. I can just do un now, I guess. Let's see. Test.un and yeah. Wait, what was that error? Okay. Build slash un. Yeah, so we don't get any errors anymore, but it does not work. Because I guess I removed some errors. Yeah, you can see it doesn't compile successfully. So yeah, it does not compile. Wait, where are we printing the file name? Right here. Yeah, we don't want to do that. I would like the error though. So where does it break? Let's see. We can go into. Let me close some of this. Let's open the code generator, and let's see. Probably makes it to here, I think. Oh yeah. Okay. Function undefined reference to print. Oh. I am have stupid. Okay. Okay. So I guess we do not make it there. So it is elsewhere. Yes, I'm not gonna worry about it. So that is, I would kind of like to have that working. I'm not gonna worry about it today though. But yeah, so this is basically the end of unnamed laying. Yes, so I'm not gonna be working on it. Let me see, did I actually? I did not. I will push it down. Removed unnecessary printfs and comments. Okay. So now it is up on the GitHub. Yeah, so I'm not going to be streaming this anymore. I'm going to move on to other projects. I've learned a lot from this project. So it's not, basically what I wrote, it's not very clean code, and it's not very efficient either. But what I've learned from it, I can use that in other projects. Because I do plan to make another programming language. I would like it to be a virtual machine-based programming language, though, because that's very interesting. I've been learning about that. So that is something that I would like to do. Basically, where you build a virtual machine. If I understand correctly, basically you have virtual machine, which basically simulates a CPU, where it has a certain instruction set, and then you have to write the assembly for your simulated CPU, so it has all the instructions, push, pop, all that, and that can compile to the bytecode for your virtual machine, which that is what it can understand. And then to make a programming language on top of that, you basically just write the syntax however you're going to be, and you lex it and parse it, and then it compiles to the assembly for your virtual machine, which then assembles into the bytecode. So that seems very interesting. I would like to do that. I'm thinking about doing that in Rust, because I've been wanting to get more familiar with Rust. So I think that could be a fun project. I've also wanted to learn about blockchains and stuff. So using C probably, I would like to look into that, try to build some stuff with that. I think that could be pretty cool. A couple other things. So on my YouTube channel, give me a second, I posted a poll. So anyone who is watching, if you want to vote on that, basically I just asked what kind of content would you be interested in seeing next. So yeah, if anything here, that's what I talked about. More programming language development, which I'm going to take a break. I'm not going to work on that yet, because I've been building this for a while now. I want to move on to something a little different. So yeah, but I would like to do that eventually. Building blockchain from scratch, that's what I was talking about. Looks like everyone's interested in that so far. Open source contributions, contributing, yeah, just to any open source project. That could be fun. I would like to do that. Exploring different types of languages, functional, OOP instead of just C, which is what I've been using basically entirely here. And I've never really done very much with functional programming, so that could be cool to learn, or something else. Comment. Yeah. So vote on this if you want to. If you want to see what I'm gonna do next. Yeah. So I think that is about it for today. Yes. So yeah, the code is here. That's the GitHub, unnamed lang. I'm going to be updating it in a bit, cleaning some things up. I'll try to get this working. I'm not going to worry about it too much, but yeah, I won't be streaming it, but I will update it here if you're interested. So yes, I can update this README now. I'll do that really quick before I am done. So, built using C for learning purposes only. Let's see. Alright, so I can get rid of all of this. The goal of this language was to compile FizzBuzz, FizzBuzz entirely, which meant writing to std out, loops, mod operator, and if statements were required, which were all implemented. To see how the syntax looks, check the examples folder. The project is not planned to go any further than its current state. Is all streamed live on Twitch, and the VODs are available on my YouTube. I think I can link it. I think that's allowed. Let's see. And then the Twitch. Okay. So yeah, I will just updated readme. Whoops. Okay. Alright, there we go. It should be updated now. Yes indeed. Alright, so thank you for